halogen derivatives. Unit of unit of BSc third sem. Okay, so let us start. Introduction. What is halogen derivative? Halogen derivative of alkanes are formed by the replacing one or more hydrogen atoms of alkane by halogen atoms like chlorine, bromine, iodine. Now if we replace the hydrogen atoms from alkane, then we get a halogen derivative. Okay. Now on the basis of number of halogen atoms present in the molecule, they are classified as monohalogen derivatives, dihalogen derivative and trihalogen derivatives, or etc. So by replacing if we replace one hydrogen atom by one halogen atom, then we get a monohalogen derivative. If we replace two hydrogen atoms of alkane by two halogen atoms, then we get a dihalogen derivative. And if we replace three or more hydrogen atoms by halogen atoms, then we get a polyhalogen or trihalogen derivative. Okay. Now generally monohalogen derivatives are as alkyl halide. Monohalogen derivative means if we replace one of the hydrogen from alkane, then we get a monohydrogen derivative that is generally called as alkyl halide. Now what is the general formula of alkyl halide or monohydrogen derivative? Monohalogen derivative. Monohalogen derivatives are generally called as alkyl halides, and its general formula is CnH2n plus 1 and X. Okay. What is the general formula of alkane? The general formula of alkane is CnH2n plus 2. Okay. One of the hydrogen, that is 2n plus 2, 2 out of this 2, one of the hydrogen is replaced by halogen atom, and therefore we have written here 1 and halogen atom. X means halogen atom. Generally halogen atom, it is denoted by X. Okay, where R is alkyl group and X is halogen. Now classification of alkyl halides. Alkyl halides are classified as primary, secondary or tertiary depending on the number of carbon bonded to the carbon with the halogen atom. Okay, now let's see here. There is a alkyl halide where the carbon atom as shown. This carbon atom is in sp3 hybridized state. Sp3 hybridized state means all it will form all single bonds. Okay, so methyl halide. Here methyl halide, in this methyl halide there are all 3 hydrogen atoms and 1 halogen atom. Now out of these 3 hydrogen atoms, if one of the hydrogen atom is replaced by alkyl group, that is R, then it becomes RCH2X. Here this carbon atom which is attached to the 2 hydrogen atom and 1 alkyl group, it is called as primary carbon atom. And if the X is attached to such a primary carbon atom, it is called as primary alkyl halide. Now second example, there are 2 alkyl groups, that means another hydrogen atom is also substituted by R. So there are 2 alkyl groups and 1 hydrogen such attached to the carbon atom. Such carbon atom is called as secondary carbon atom, and such alkyl halide is called as secondary alkyl halide. Now if all the 3 hydrogen atoms are replaced by R, that means the carbon atom is attached with the 3 alkyl groups and 3 alkyl groups, then that type of alkyl halide is called as tertiary alkyl halide. For example, 1-iodopropane. So this is the primary alkyl halide because iodine is attached to the primary carbon atom. Why it is primary carbon atom? Because it is attached to the 2 hydrogen atoms. Okay, and 1 alkyl group. Alkyl group is ethyl group here. So this is a 1-iodopropane, or it is a primary alkyl halide. In second example, this Br is attached to the secondary carbon atom. Why it is secondary carbon atom? Because this carbon atom is attached to only 1 hydrogen atom, and all the other valencies of that carbon are satisfied by 2 alkyl group. Therefore it is called as secondary carbon atom. And third one is the tertiary carbon atom. Okay, why it is tertiary? Because there is no hydrogen atom attached to the carbon atom, all the three bonds of carbon are attached with the 3 alkyl group, and therefore this is a tertiary carbon atom and called as tertiary butyl halide or tertiary butyl chloride, chlorine है करके. Now nomenclature. In common system, monohalogen derivatives are called as alkyl halide. Okay, जो कुछ भी alkyl group है उस alkyl group का नाम it may be ethyl, methyl, butyl etc. and जो कुछ भी halogen है, if it is chlorine then it is chloride, if it is bromine then it is bromide, if it is iodine then it is iodide etc. Okay, so in common system monohalogen derivatives are named as alkyl halide, but in IUPAC system they are named as haloalkane. Okay, haloalkane etc. If we can take the examples of this. So first example is CS3Br. CS3Br in common system its name will be, it is a methyl group and it is a bromide, therefore it is called as methyl bromide. But in IUPAC system its name will be methane. Okay, CS3 there, therefore it is a methane, bromomethane. Second example is CS3CH2Cl. So in this second example ethyl, that is the alkyl group is the ethyl group and the halogen atom is a chlorine, therefore it is called as ethyl chloride, and in IUPAC its name will be chloroethane. Similarly in third example, so this is the alkyl group is N-propyl group and halogen is chlorine, therefore its name is N-propyl chloride. Okay, and its IUPAC name is 1-chloropropane. Why there is 1? Because this chlorine atom is attached to the first first carbon atom of the state chain. Okay, therefore it is called as 1-chloropropane. Okay, then the fourth example. In this fourth example, this is a propyl group. Okay, actually it is an isopropyl group. Why it is called isopropyl group? Because this middle carbon atom is attached to the two similar methyl group. Okay, or two methyl groups. If it is attached, C carbon atom is attached with the two methyl group, then that group it is called as iso group. Okay, so it is called as isopropyl chloride, and in IUPAC, while writing the name in IUPAC, okay, it is a branch chain, therefore we have to number this chain. Consider a longest chain. This chain is of 3 carbon atom, therefore its corresponding alkane is propane. We have written propane here, and this chlorine atom is attached to the second carbon atom. We can start the numbering from any end in such a way that the halogen atom, or it is called substituent, is nearest to that carbon atom. Okay, so to that end, from that end we have to start the numbering. So here we can start numbering from any carbon atom, because the position of the carbon atom attached to the is same. Okay, therefore it is called as a 2-chloropropane. Fifth example is alkyl. Here alkyl group is N-butyl group, therefore in fifth example its common name will be N-butyl chloride, and its IUPAC name is 1-chlorobutane. Since why it is 1-chlorobutane, chlorine is attached to the first position and the longest chain is of butane. Okay, that its corresponding alkane is butane. Now in sixth example, the longest chain is this chlorine is attached to the secondary carbon atom, because that carbon atom is attached to only one of a hydrogen atom. That carbon atom is called as a secondary carbon atom. So here the chlorine atom is attached to only so chlorine atom is attached to secondary carbon atom, therefore it is secondary, and the alkyl group is 1 2 3 4, secondary butyl and chloride, so its common name will be secondary butyl chloride. In IUPAC name we have to consider a longest longest chain. So the longest chain is of 1 2 3 4 carbon atoms, that means its corresponding alkane is butane, if we number this chain, then from that numbering, the chlorine atom or the substituent, any substituent, it must be closest to that number, to the that starting point. Okay, it must be closest. So if we start from this CS3 on left hand side, then the number of carbon to which the chlorine is attached is a second. Therefore we will start counting from this carbon atom. So this is a 2-chlorobutane. Okay, then seventh example. uh, so in this example also, so it is a isobutyl group, CS3CH, it is, and CH2. This is a isobutyl group. So isobutyl group, and the halogen atom is chlorine, therefore its name is isobutyl chloride. Okay, why it is called isobutyl group? Because the group, this is attached, the carbon atom or CH2 group is attached, sorry, chlorine atom to which, sorry, CH2 group to which the chlorine atom is attached, it is attached, also attached to the CH3 that means there is a two branch of CH3, so therefore it is called as iso. And all carbon atoms are of butyl and chloride. Halogen is chlorine, therefore it is a chloride, therefore it is isobutyl chloride. And its IUPAC name is, here again we can consider the longest chain. We can see that the longest chain is of 3 carbon atom and its corresponding alkane is a propane. Therefore from right hand side carbon atom we can start the numbering. Therefore it will be 1 chloro, because chlorine is attached to the first carbon atom, therefore it is 1 chloro. To the second carbon atom there is a methyl group, therefore it is 2 methyl, and the longest chain is of propane, therefore propane. The longest chain is of 3 carbon atom, therefore its corresponding alkane is propane, therefore its name in IUPAC is 1 chloro 2 methyl propane. Okay, similarly in 8th example, this group, we can see here the carbon atom is attached to the 3 methyl groups and then CH2I. So this group, it is called as neo group. If the carbon atom, one of the carbon atom is attached to the 3 methyl group and it is also attached to the CH2 to which the halogen is attached, then that is called as a neo group. And total number of carbon atoms here are 5, therefore it is neopentyl iodide, and halogen is iodine, therefore it is neopentyl iodide. Okay, and in IUPAC system we can number it, we can take a longest chain, we can consider a longest chain in which there is a halogen atom. So we can consider this CH3C CH2I, ये जो चेन है उसको अपन longest chain मानेंगे. So here there are 3 carbon atoms, its corresponding alkane is propane. Iodine is attached to the first carbon atom, therefore it is called as 1 iodo. We have to start from this carbon to which iodine is attached. So this is 1 iodo. To the second carbon atom there are 2 methyl group, therefore it is 2 2, 2 methyl है करके dimethyl propane. Okay, 9. In 9th example, this group CH2 double bond CH, this group is called as vinyl group. Okay, and it is attached, this vinyl group is attached to the bromine, and therefore its common name will be vinyl bromide. Okay, that means the vinyl bromide. In IUPAC name we can write it as halo means bromo, इथीन है करके इसको यहाँ पे लिखेंगे अपन इथीन, it is bromoethene. And in 10th example we can see that this group is allyl group. You very well know about the allyl group because in last year we have seen about this. CH2 double bond CH, single bond CH2, this group is called as allyl group, and therefore it is allyl bromide, and we can write its IUPAC name as. So now here we have to give a preference where the double bond is attached to the chain where the double bond is attached. Um, Therefore, we have to start the numbering from the that carbon atom to which the double bond is closest. So we have to start the numbering from the left carbon atom. So 1, 2, and 3. Therefore, bromine will be at third position. Therefore, 3 bromo, and it is a propene. Since the double bond is in first position, we can write it as 3 bromo propene 1 or 3 bromo propene. Okay. Now methods of preparations of alkyl halide. We can prepare, you very well know it. We can prepare alkyl halides from alkane by halogenation. So in presence of sunlight, we know that when methane is or ultraviolet light, when methane or any alkane is treated with halogen, then the hydrogen atoms from alkane gets replaced by that halogen and we get alkyl halides. Okay, if the reaction goes up to all the hydrogen atoms from alkane gets replaced by the halogen atoms. So this is the example where we get methyl chloride. The reaction may continue further till all the hydrogen atoms of this methane gets replaced by Cl, but we are going to see here only the preparation of alkyl halide. Therefore we have obtained here methyl chloride. Okay, so in presence of sunlight, when alkane is treated with chlorine or bromine, that means halogen, then we get alkyl halide. From alkene, so alkene reacts with halogen acid. Halogen acid means HX to give alkyl halide by addition reaction. Now here we have taken alkene. It is a symmetric alkene. Why it is symmetric alkene? If the two double bonded carbon atoms are attached to the same groups or same atom, then it is called as symmetric alkene. In case of symmetric alkene, if we treat halogen acid, then simple addition reaction takes place. Any of the atom, that is hydrogen or halogen, may get attached to the any double bonded carbon atom. So we get alkyl halide like this. So for example, ethene, it is also a symmetric hydrocarbon. Ethene is a symmetric hydrocarbon. Therefore we get a product here, the ethyl bromide. Similarly, 2-butene, it is also a symmetric alkene. Sorry, it is a symmetric alkene. Therefore on treatment with HBr we get ethyl bromide here. Similarly, 2-butene or butene 2-butene, it is also a symmetric alkene. When symmetric alkene is treated with halogen acid like HBr or HI or HCl, then there will be a simple addition reaction. Hydrogen is attached to any one of the carbon atom and bromine is attached to the other carbon atom. So we'll get 2-bromobutane in this case. Okay, but if there is a unsymmetric alkene, unsymmetric means like 1-propene. Okay, CH3 CH double bond CH2. Here the double bonded carbon atoms are not attached to the similar groups or atoms. Therefore such alkenes are called as unsymmetric alkene, like 1-propene. So in case of 1-propene, when we treat this with halogen hydrogen halide, that is HI, hydrogen halide, then the addition of a hydrogen, we get simply we will see first. So we will get two products, like this hydrogen may get attached to the left hand side carbon atom, or it may attach to the right hand side carbon atom. Okay, so first if we see this first example, then hydrogen is attached to this left carbon atom and we get the product like this, which is 1-iodopropane. In second reaction, we have attached this hydrogen atom to the right hand side carbon atom and iodine to the left hand side carbon atom. So we get here the 2-iodopropane. But according to Markovnikov's rule, this addition will takes place in such a way that the negative part of this reagent means hydrogen halide, the negative part of the reagent here, which is I minus, goes to that carbon atom which contains less number of hydrogen atoms. That means iodine I minus will go to this carbon atom. Which carbon atom? Left hand side carbon atom, because it is contains a less number of hydrogen atom. There is only one hydrogen atom in left hand side carbon atom, or left hand side carbon atom is attached to only one hydrogen atom. Right hand side carbon atom is attached to two hydrogen atom. Therefore, according to Markovnikov's rule, the measure in addition of asymmetric reagent to the asymmetric unsymmetric alkene, the negative part of the reagent goes to that carbon atom which contains less number of hydrogen atom. So, according to Markovnikov's rule, the second product, that is 2-iodopropane, it is the major product. Why? Because the iodine is attached to the carbon atom which has less number of hydrogen atom. Okay, so this is called as Markovnikov's rule. Now, if the same reaction is carried out in presence of peroxide, what is meant by peroxide? Peroxide means the compound which contains oxygen linkage, O-O linkage जिस compound में रहता है. For example, hydrogen peroxide, HOOH. So this is called as peroxide. If the same reaction is carried out in presence of peroxide, then anti-Markovnikov's rule occur. Anti-Markovnikov's rule means what? Means the negative part of the reagent goes to that carbon atom which contains higher number of hydrogen atom. Okay, therefore, suppose if we treat 1 propene with HBr in presence of peroxide, then this bromine atom Br minus will attach to the CH2. Why CH2? Because here the carbon atom has two hydrogen atom. Therefore, and that hydrogen atom in hydrogen halide will attach to the CH. Okay, or left hand side carbon atom, hydrogen will attach to the left carbon atom, and Br minus will attach to the right hand side carbon atom. So this occurs in presence of peroxide, and therefore, since here 1-bromopropane, it is the major product, we call this reaction as an anti-Markovnikov's rule, or addition of hydrogen halide in presence of peroxide. It is called as peroxide effect or anti-Markovnikov's rule. So when in addition of asymmetric alkene to the asymmetric reagent like HBr or HI, if the reaction is carried out in presence of peroxide, then the negative part of the reagent goes to that carbon atom which contains higher number of hydrogen atoms. Okay, so if in peroxide, it is called as peroxide effect. In peroxide, 1-bromopropane, it is the major product. If in absence of peroxide, the same addition will takes place according to Markovnikov's rule. Is the addition of hydrogen halide to the unsymmetric carbon to the unsymmetric alkene will take place in such a way that the negative part of the reagent or hydrogen halide, that means halide ion, will go to that carbon atom which contains less number of hydrogen atom. So these are the products. It is anti-Markovnikov's product which is in the presence of peroxide, and second the product is in absence of peroxide, that is 2-bromopropane. It is in accordance with the Markovnikov's rule. So next is from alcohol. We can prepare alkyl halides from alcohol by different methods. First, by action of PCl5 or PBr3, we can prepare or we can replace OH from alcohol by halogen atoms. So above is the reaction of the alcohol with PCl3. Here we get uh, this OH group is replaced by Cl, and it is phosphorus acid is liberated. So for example, ethyl alcohol, when ethyl alcohol is treated with PCl3, we get 3 ethyl chloride and phosphorus acid H3PO3 is byproduct. Similarly, if we treat the ethyl alcohol with PBr3, then ethyl bromide will be obtained and phosphorus acid is byproduct. Similarly, we can also replace the OH from alcohol by halogen by treating it with PCl5 or PBr5. Okay, so this second reaction is not correct. Kindly remember this first reaction in the action of PCl5 or PBr5. Okay, in this second reaction there should not be three. Okay, there should not be three alcohol molecules. There should be only one alkyl molecule, and it will form a 1 mole of this ethyl bromide also. Okay, so that is the correction here. In first reaction, ethyl alcohol is then treated with PCl5. There is no need of 3 moles of alcohol. Only 1 mole is sufficient, or only 1 mole is required. 1 mole alcohol is required to react with PCl5 or PBr5. Okay, so we get a 1 mole of ethyl chloride or ethyl bromide, and the products are phosphorus oxytrichloride and HCl. Byproducts are phosphorus oxytrichloride and HCl. The main aim of this reaction is, by this reaction we can convert the OH group from alcohol into the halogen group. Okay, that means these alcohols, it can be converted into alkyl halides by treating it with PCl5 or PBr3 or PBr5 or PCl3. Okay, similarly we can convert this alcohol, uh, ethyl alcohol, into ethyl chloride by treating it with the thionyl chloride. Here there is a liberation of SO2 gas and HCl gas. So when we treat, here only alkyl chlorides are obtained because there is the reagent is associated to therefore here only alkyl chloride is obtained. So when we want to prepare alkyl chloride from ethanol, we can treat it with either SOCl2 or PCl5 or PCl3. Okay, so these are the methods of preparation of alkyl halides. Last one is of same pattern, where we can treat alcohol with HBr in presence of a zinc catalyst, zinc